All right, everybody. So here is homework help with rotation number 1. And let's take a quick peek. Not too long of an assignment. Shouldn't take too long at all. Okay, so for question number 1, you'll notice you'll be given a function for theta. And here's the one on this piece of paper, in case you can't read it. And you're asked to find position, speed, and acceleration at 2 different times. The main thing here to keep in mind is that if you take the derivative of theta with respect to time, you're going to have your angular velocity function, and if you take the derivative of the angular velocity function with respect to time, you're going to have your angular acceleration function. Actually, I should probably put little functions in there, right? Put a little respect to time, and then you can plug and chug and figure out your values for those. So not too tough. Number 2. You're given, starts from rest, you're given an angular acceleration. Again, it's a function. Determine the angle in radians we want theta, through which the bar turns in its first 4.58 seconds. So we know time, we know initial velocity of 0, or angular, I should say initial angular velocity of 0. Okay, so what I would suggest here is, since you know the acceleration as a function, is to use the time to find the value of that, and then use kinematics and use the proper kinematic equation to solve for theta, because that's what it is that you want there. Okay, next, number 3. Again, let's see, we start from rest, so my initial angular velocity is 0. Constant acceleration, you're given a final speed here, you're given time here. Asked to find alpha, asked to find theta. Again, these are straight kinematics functions, so if you look at what you know, pick a formula that is missing this one, and then once you've got that, use another kinematics formula to solve for this one. Not too bad. Your acceleration is constant, so there's no calculus involved at all. Okay, when switched off. All right, again, another kinematics one here. We're looking for alpha. Notice, though, our units, you're given revolutions per minute. You want to make sure that you change these into radians per second. And this, of course, is our initial angular speed. Your final angular speed is going to be 0 because it's being switched off, and you are being given how many revolutions it's going to go. So you're being given the theta here. You'll need to do a little converting, but once you have this converted into radians and you have this one converted into radians per second, it's a pretty straightforward angular acceleration. Using use kinematic equation and solve for your angular acceleration. So hopefully that helps you out.